Nothing lasts forever. These words cannot be more true, especially when applied to the ever-changing landscape of planet Earth. Given time, even the mightiest of mountains and the most elegant of rivers will forever be altered, perhaps even polar opposites of their former selves. In this video, we will document and explain some geographical occurrences along Canada's west coast, a region steadfastly changing to nature's whims. We begin our journey at Whitecliff Park, a location with arguably the most diversity out of any of our stops. To the naked eye, this area might seem like any other, a beach with some mountains, but pulling back the curtains reveal a much more complicated collection of geographical features.
Alright, here there's a spit present. The spit is connected to the tombolo. A spit is a piece of land that projects out to the sea from the mainland. The spit is connected to an island. A tombolo would form.
One of the most well-known tombolos is Chesil Beach in England. This area is a UNESCO World Heritage Site because of its unique formation and abundance of dinosaur fossils around the beach. The tombolo is connected to a large limestone island with a population of about 12,000.
The beach is made of glacial till. It is an accumulation of sand, mud, rock, and pebbles. Because the tombolo is essentially an island connected to a spit, the area around the tombolo was once land. Hydraulic action has eroded the land due to a heavy sediment load. Wave-cut platforms form because of destructive waves. These waves are always eroding, and they have a weak swash, but a very strong backwash. A mark in high and low water is created from abrasion, attrition, hydraulic action, and corrosion.
There are four main types of erosion. Attrition, where rocks bang on each other. Abrasion, where rocks scrape on each other. Corrosion, where chemicals erode rocks. And hydraulic action, where water erodes rocks.
In frost wedging, water enters the cracks of rock, freezes, and expands the cracks of the rock. In root action, roots and trunks erode through the rock.
There are two main parts to a wave, the swash and the backwash. The wind causes the swash to come in at an angle, while the backwash always leaves at a 90-degree angle. When magma flows through vertical cracks towards the surface, it cools quickly and forms a basaltic dike. Intrusive rocks cool slowly and solidify underground, thus creating big crystals. Now, extrusive rocks are the opposite, where they cool quickly and they form above ground, creating small crystals.
Basaltic dikes are named aptly after their main component, basalt. Basalt, as explained before, is a quick-cooling extrusive volcanic rock that appears in abundance in, as well as on, Earth's surface. Basalt is found under approximately 7% of Earth's land surface due to lava flows, volcanic eruptions, or other natural occurrences involving molten rock. Basalt is used in construction for the creation of cobblestones or for stone wool, an excellent thermal conductor.
On either side of this tombolo is a headland and a bay. A bay forms because softer material gets eroded away faster by the water. Headlands consist of harder material, thus making it harder to erode by water.
Depending on how much hard rock the land possesses, a headland's size can vary. Large headlands are called capes. In addition to hydraulic action, capes can also be eroded or created by either glaciers or volcanoes. Examples of famous capes include Cape Cod in Massachusetts, Cape of Good Hope in South Africa, or Cape Canaveral, the site of many space expeditions conducted by NASA.
Harvey Creek, our second destination. The main ideas here are the debris dam and the mitigation features. What lies behind the debris dam is a reservoir. Slides and debris flows are characteristics of mass wasting. Humans have needed to adapt to the surroundings through many ways because of loose glacial deposits, steep slopes, mountain stream basins, and precipitation. Lions Bay Village is one community that has had to adapt to the hazardous conditions of the sea to sky corridor. From 1980 to 1984, Lions Bay suffered from a landslide. It killed 12 people, destroyed 9 bridges, and many homes. The town around this area is built on material that has once been loosened by the surrounding amounts of water. The water is prone to be absorbed by the soil and triggers mudslides. The mitigation features should also be noted. Their placement and construction is crucial and key to the function of the debris dam and adds a supporting layer to the unstable loose ground and slopes.
The purpose of the debris dam was constructed to prevent heavy debris and mud flows. It limits the amount of material that can pass through.
In a slope, the angle at which it is stable is called the angle of repose. Large volumes of sediment cause slides. Heavy rainfall impacts the flowing speed, which can alter the repose angle to be unstable.
When a mudslide occurs, it moves trees and surrounding soil to a lower, more stable location. When the trees are finally settled, they begin to grow up towards the sun, correcting their angles changed by the mudslide. This feature is called geotropism, and it is why some trees are shaped like the letter J.
Mitigation features such as shotcrete and drainage pipes are used to divert water and/or reinforce slopes that are affected by heavy precipitation. Porto Cove, a beauty of a scenery. Once a U-shaped valley long ago, now it is being submerged with water, forming a glacial feature called a fjord. Human adaptations, such as coral scuba diving, lies here. More glacial features, such as moraine, roche montanaise, and cirques, are present here. The beach adds another layer of aesthetic as well. On the topic of the coast, the type of wave present would be a constructive wave. It has a strong swash, weak backwash, and most importantly, it is always depositing sediment and material.
Over here you can see a truncated spur and a roche montanaise. These are formed by glacial movement through the process of abrasion. Because the highest point of the roche montanaise is on the right side, we can tell that the glacier came from the left to the right.
Roche montanaise are related to two more geographical structures, the crag and tail and the drumlin. The crag and tail is made up of two parts, the hard, steep side that gets eroded by a glacier, and the softer side left behind as the gradually declining tail. The Edinburgh Castle sits on top of an impressive crag and tail. A drumlin is a long hill composed of loose boulders, dirt, and clay. They are thought to be formed when a glacier piles a loose material on the center of the hill. A lot of drumlins have plant life growing on them, making them hard to identify.
This beach is composed of terminal moraine. Terminal moraine is small pieces of rock plucked out from a mountain by a glacier and deposited at its furthest extent. A type of weathering that occurs on this beach is spheroidal weathering. Spheroidal weathering is when water wears down a rock into spherical shapes, as seen here. As you can see, oxidation is here. Oxidation occurs when oxygen in the air reacts with the metals in the rock to wear it away.
Now you see there, that's a cirque. The glacier before would have been in that area on this cirque. This entire area around us, before glaciation, would have been land. Now, post-glaciation, this is all water. We are currently standing in the middle of a fjord, which is a U-shaped valley that is filled with water.
Maritime polar air masses are air masses that form over cool bodies of water, such as the Pacific Ocean.
Air masses are giant groups of air that take on different characteristics determined by the area they form over. Characteristics include either moist or dry, and warm or cold. A warm, moist air mass is called a tropical maritime air mass, and a cold, dry air mass is called a polar continental air mass. These air masses take on these characteristics largely due to the angle of incidence. The angle of incidence is the concentration of the sun's rays contacting Earth in a given location. Air masses around the equator are warmer due to the fact that the sun's rays are more concentrated there, while near the poles, the sun's rays are more dispersed, leading to colder air masses. The angle of incidence also affects weathering. As water doesn't freeze naturally at sea level near the equator, the main erosion is chemical. Where water does freeze near the sea level, mechanical weathering dominates the landscape. Different air masses have different air pressures. When two air masses with varying pressures collide, they can create wind, clouds, rain, and even tornadoes. On the west coast, we are affected by moist air, which contains stormy weathers and strong winds. We are also affected by cold air, which also happens to bring rain when met with warm air.
When the clouds of a maritime polar air mass come through over these mountains, as they rise, they cool, condense, and create orographic precipitation, leaving us with this lush, green side of the mountain. Since orographic precipitation occurs in abundance here, it can affect the angle of repose. The angle of repose is the angle at which material is steady. A lot of rain can disrupt this angle and cause mudslides.
We've arrived at Shannon Falls. It is a famous example of a hanging valley. The waterfall drives down and runs the Shannon River, a youthful river in it itself. Some notable processes to mention and to look out for here are glaciation, and how the glacier creates the hanging valley, truncated spurs, rock striations, glacial till, and such else. Also to look out for here are mechanical weathering, and the youthful river and its many characteristics.
As you can see, this is a youthful river. Youthful rivers have high gradient, high velocity, but a very low sediment load.
There are 3 stages of rivers, the first being youthful, as we just discussed, the second being mature, and the last being old. Mature rivers are rivers that lack fast, rapid-like waters, and as a result, have higher sediment load. These rivers meander. A meander is where a river twists and turns through usually a level terrain. An example of a mature river is the Mississippi. The gradient of rivers gets smaller as the river's velocity slows. An old river has very slow waters, and therefore has high sediment load. These rivers meander often. An example of an old river is the lower part of the Nile. There are 3 different types of sandbars: braid bars, point bars, and mouth bars. Braid bars occur in braided rivers, or rivers that split into multiple channels, separated by braid bars. Point bars are built up in meandering rivers, and mouth bars are built up at the end of rivers, creating what's called a delta. Deltas are formed at the ends of an old river The high sediment found in old rivers are deposited at the mouth, resulting in many small islands teeming with diverse life. Not all old rivers form deltas. The ocean or body of water receiving the sediment must have docile currents and little to no longshore drift, or the moving of sediment through waters, swash and backwash.
As you can see here, these are striations. These are lines created by glacial movement. Through abrasion, the glacier has polished these rocks down to a fine, smooth surface.
Because we can see these striations today, means that the glaciers have receded due to the fact that the glacier melted faster than snow can accumulate and compact on the top of the glacier. This new ice formed at the tops of glaciers is very important, as it adds to the weight and increases the force of gravity on the glacier, leading to more erosion.
There are 4 types of sediment river transportation: traction, saltation, suspension, and solution. Traction is where the high velocity of a young river pushes large rocks against the bottom of the river. Saltation is where smaller rocks skip along the bottom of the river. Suspension is where even finer sediment is suspended inside the river as it moves. And solution is where the sediment is so fine you can't even see it.
When the water from underneath the glacier gets into the cracks of a rock, freezes, and then expands at 9%, it is called sapping. Imaginary fall line is created when parallel rivers flow and fall from the highlands to the lowlands. Headward erosion is present at the bottom of this waterfall. Soft rock erodes, leaving a hard edge for the stream to fall over.
In the soil, there exists many rocks that look like they belong to the mountain. These rocks belong to a collective group called glacial till, which is the pieces of mountain glaciers have carved and ripped out over many years and deposited on the grounds of the surrounding area. Lateral moraine, very similar to glacial till, is the name for rocks deposited on the sides of glaciers. These rocks are carried by the glacier very far until the glacier inevitably melts. When a glacier melts in a continental plain, it creates what is called an outwash plain, an area covered in small rocks and erratics, which are big rocks that seem out of place. Glaciers also have a big effect on the shape and function of mountain ranges. We owe the distinct and lovable shape of mountains to the destructive force of the glacier. An arête, or a sharp mountain ridge, is the feature most people outline when recalling the shape of a mountain. When 3 arêtes join to a point at or near the summit of a mountain, they form what is called a pyramidal peak. The Matterhorn in the Swiss Alps is a popular example of this. A long, thin stretch of glacial till in a continental plain is referred to as an esker. Eskers are notably important to the infrastructure of a region due to the ease of creating roads or highways on the gravel left by glaciers. If a road is not needed, then the gravel can be sold as it is in abundance. Truncated and interlocking spurs occur at or near the base of a mountain, typically within a U or V-shaped valley. Truncated spurs form when a glacier wears away the ends of spurs, leaving smooth and steep edges we see on truncated spurs. Truncated spurs are found in U-shaped valleys. Interlocking spurs are spurs that occur in rows alternating from left to right, like teeth on gears. These are typically found in V-shaped valleys.
Whistler, one of the most popular and most visited tourist destinations in Canada. People from all around the world travel to Canada just to visit Whistler. In Whistler Village, many services and evidence of human development is present. The Whistler Gondola takes passengers up a steady elevation of 436 meters. Another ski lift, not far from the gondola, provides quick access to the Whistler Blackcomb Ski Resort at the peak. During the winter months, skis and snowboards are the most commonly used equipment. But in the summer, when there is no snow or ice, bikes dominate the majority. In addition, a policy states that in the summer, people have to bring their own or rent a bike to ride the ski lift, and in the winter, skis and snowboards are used. They also get to ride on free of charge. Tree trek tours, Canadian snowmobile and ATV adventures, coast mountain photography and video. The pubs, restaurants, gift shops are just some of the many services available in Whistler Village. Not to mention the countless hotel lodges and bike shops such as the Pangea Pod Hotel, Whistler Peak Lodge, Deer Lodge, Bear Lodge, Eagle Lodge, Fanatic Co Bike Shop, and many more to name.
Brandywine Falls is a fascinating area to visit, as it features not only a breathtaking 70-meter tall waterfall, but also houses the impressive stratovolcano Mount Garibaldi in close proximity. The land also holds an array of geographical processes in abundance. Areas like Brandywine Falls are subject to frequent change. The force of gravity pulling the falling water down is great enough to cause sufficient weathering given enough time. This form of weathering is called headward erosion and causes the waterfall and subsequently the river to migrate backwards in a slow but inevitable process.
As you can see there, we have columnar joints. Columnar joints are formed from cooled lava. It then solidifies and cracks the rock to create those vertical lines.
Columnar joints are plentiful on the west coast due to the Ring of Fire. The Ring of Fire is a line that wraps around the Pacific Ocean, indicating areas of frequent volcanic activity. The Ring of Fire reaches as far north as the Aleutian Islands in Alaska, all the way down to New Zealand, and pretty much all coast to the left and right of these areas. This ring of subduction explains why there are so many trenches in the Pacific Ocean. Europe also has their own Ring of Fire. Located in the Mediterranean, specifically Italy, it is nicknamed the Mediterranean Belt of Fire.
Those horizontal lines are indicators of the different layers of ash and volcanic rock.
This is a stratovolcano. It forms when molten rock spews out of the magma chamber and cools on the side, creating layers of ash and pyroclastic material.
This buildup of ash and lava on the sides and surrounding areas of stratovolcanoes takes at least tens of thousands of years to create through many eruptions. A popular eruption of a stratovolcano in recent years is Mount St. Helens, not far from Garibaldi. The last eruption from Mount St. Helens was in 2008, but a much more powerful eruption occurred in 1980, when, in a terrifying showcase of strength, Mount St. Helens decimated not only a large surrounding area, but also itself. Recently, in the volcanic depression, also known as a caldera, of Mount St. Helens, a new volcano has been growing using the same buildup of layers. Other types of volcanoes include shield and dome volcanoes. Shield volcanoes are characterized as having low-lying peaks with a very gradual incline as you ascended. Dome volcanoes possess sides steeper than shield volcanoes. This is because viscous lava from dome volcanoes cool closer to the top since it flows slowly. Our final stop is the Squamish Chief, a whopping 700-meter tall granite monolith, the second tallest of its kind in the world. The Squamish Chief is the crown jewel of Canada's west coast, and the magnificent natural structure serves as one of Canada's most well-known physical features.
When magma in the Earth's crust cools, it gets pushed up due to tectonic uplift and leaves us with a batholith, as we see today. A type of erosion that forms on batholiths is exfoliation, where
Exfoliation is a type of weathering that is present on the chief. Exfoliation occurs when the pressure formed by overlying materials is reduced, in this case because of tectonic uplift, where two tectonic plates collide, forcing one to lift up above another. The reduced pressure creates an effect where pieces of the rock flake off in small amounts. The overlying materials that help build pressure on batholiths can be ice or other rocks.
Dikes form when magma enters into a crack vertically. It then solidifies as a sheet, cutting across layers of rock.
As just mentioned, dikes are formed when lava cools in the pre-existing crack of a large rock. These are called magmatic dikes. But magmatic dikes aren't the only type of dike that exists. Another type is a clastic dike. This forms when sediment instead of lava fills a crack on a rock. Diagenesis may also play a role in the formation of clastic dikes. Diagenesis is where sediment converts to sedimentary rock, something needed for clastic dikes. This can be due to lithification, where pressure morphs sediment into rocks.
From the alpine glaciers to the volcanic tectonic activity, natural processes shape the function and appearance of the geographical environment. All these features, once obscure to the common person, should change their perspective of the world around them.